Today I will be introducing the ABC Bank notebook. Um, so for the object of this project is to build machine learning model that predict whether a credit card application is approval or denied. So it's a binary classification problem. And the purpose of building the model is to help the bank to improving decision making, risk management, and cost control. So we input the data into and we can find we got to hit to this place. Um, right here, it shows we have the data set contains about 10,000 um observation and 20 features, um, including demographic, financial, and behavioral variables. And there are no there are no missing values by the features. There are no duplicate records. The target variable is binary, where one indicate approval and zero indicates denial. We're using the auto viz class to a library. We visualize um, the feature distribution and dedicate skewness in numerical variables such as total income, um, years employed, and the number of the children. And to clean the pre-processing, we goes to here pre-processing. The ID column was dropped because it has no predictive value. And for category variables such as income type, education type, family status, housing type, and occupation type, um, we apply the label encoding, convert them into numerical representations suitable for the machine learning models. The heat map also tells us a lot of things. First is the relationship between age and unemployee. Second is the number of children and the number of family. For distribution, of course, we want it to be more symmetric rather than skewness of right or left. And then after standardized or predictive, we use the PCA to analyze the variance structure. The cumulative explained variance plot shows the relatively small number of principal component can be explained most of the variance. It's very difficult to give a story based on the PCA cumulative explained variance, which is this line. It has this has done that has to do with the PCA's limitation, and the after this we did a random forest classifier to capture features importance scores, which identify which original variables such as income, employment length, years employed, and age has a very strong influence on predictions. This feature importance are particularly valuable in banking, where it helps to build better model. And this it seems like the model captures all denials, but no approval, which is why the accuracy is so high. And with 85%, 85% extremely good, but the model will do as good as well with another 85%, even with approval. So just because the model only, I believe, captured the all the denials in this case. So the model basically did poor job, in my opinion. And after using with the k-means clustering, the model actually did not improve much. You may say even the poor. So then we use the H2O AutoML. Um, This graph only gives us tells us that the H2O service has started and the AutoML training has been completed successfully. Um, and to here is the output shows the prediction processing of different model inside of H2O AutoML has been confirmed and all the model finished the evaluation successfully. And this is the result. So the first column is the model ID, all the name, which is just the model names. It doesn't have any specific meaning. And the algo is the algorithm that was used. And AUC means how the model distinguished between denial and approval. They all around 0.55. Um, Accuracy is extremely good. However, precision is not all good as accuracy. This is really interesting. This might suggest the model predicts and improve predict the approval incorrectly. The last column is record recall. In this case, high recall is necessary because record measures how many extra approvals that the model successfully captures. Um, the data preparation and features engineering directly affect how the model performs. The numerical clean normal distribute input will definitely give beautiful logistic regression. Also, not all the features engineering will make the model better. For example, the k-means did not improve the accuracy as we see right here. And we did encoding the categorical variables allow the algorithm to process data effectively. The PC helps analyze the variance structure, but also reduce the interpretability. And the graph cannot give much information from the k-mean clustering, did not give a clear predictable value either. The auto ML shows all the output and easy to compare. Um, um, and also, I mean, easy to compare with all the algorithm, as you can see. There is definitely a class imbalance problem need to be fixed. Just because, especially in this case, the bank wants to make sure they keep all the approvals, means they keep all the good clients, also deny all the bad clients as well. The model is 85% accuracy, but it's because the model only knows how to deny rather than capture the approvals. And the feature selection may also have some space to improve, in my opinion. And for the real world patterns and implications, the age, years employed, and the income were the top three features in this case. In financial related business, age, years employee, and income indeed matter a lot in credit approval. So, and another stuff is the feature engineering does not always guarantee improvement on the output. Also, accuracy could be misleading in this case.